So today we are going to be talking about rotation of plane mirror. We've been talking about reflection and we've been able to solve problems on reflection. So in this video, we're going to be talking about rotation of plane mirror. So I am going to be starting from the beginning, okay, so that we will be on the same page. So I'm going to be starting from the beginning. So what do we know about reflection? So we have this. Let's say this is the plane mirror. This is the plane mirror, okay? And then we have the incident ray, the reflected ray, okay? Of course, this is the normal, okay? So let's call this normal. This is the incident ray. This is the reflected ray, okay? Now, we are talking about rotation of plane mirror, okay? Now, this is the mirror. Now, if we are to rotate the mirror, rotate it like this, okay? So, if we rotate this mirror like this, okay, let me label this. So, this one we have here is the angle of incidence. This one is what? The angle of what? Reflection. I'll still say it again. You remember that the angle of incidence is usually the angle between the incident ray and the normal, while the angle of reflection is the what? The angle between the reflected ray and the normal. This is it. Okay. Now, we want to look at want to see what happens if the mirror is rotated through an angle. Okay, if we move the mirror through an angle, what will happen? What will happen to the angle of incidence? What will happen to the angle of reflection? Okay, will it still be the same? Okay, will it still be the same? Let's do this and see the result. So if we are to tilt this mirror or rotate this mirror like this, so this is our mirror. It has been rotated through an angle, okay? So we have this, the mirror. Let's assume you are not seeing the old one, and then we rotated the mirror through an angle, okay? We rotated it in this direction, and of course, if you move it like this, it means this side will move in this direction, while this one will move in this direction. So we'll have this. Do you follow? If you tilt the mirror, you tilt it in this direction, this side will move up, this side will move down. Okay, so we have this. Let's label this normal one, because we are going to be having another normal for this mirror. And let's label this R1, because we are going to be having another reflection. Okay, no, the incident ray is not changing. Okay, we are still going to be maintaining the incident ray, so the incident ray is not changing. Okay, so when an incident ray of light hits on a plane mirror, okay, we have what we call the reflection. Reflection happens. Okay, now we are going to look at what if the mirror is rotated through an angle. So let's say the angle is what? Theta. The angle is what? Is theta. The angle is what? Is theta. So now we are going to be having another normal, okay, for this. This is we are still using this incident ray. So the normal is going to be this, right? So this will label it as what? Normal 2. Mind you, this is the incident ray, okay? So now the incident ray is not changing. The incident ray is maintained. So if you have this as the incident ray, this is the normal. So it means we'll have reflection, right? This is reflection. So we'll call this one R2. Okay? So now this is the normal for the rotation, for after rotation, sorry. This is the normal for before rotation. Are you seeing? This is the normal before rotation. This is the normal after rotation. Okay? So now the angle of incidence after rotation will be what? The angle of incidence will be this, from here to here. Okay, and now This angle between the two normal is tagged theta. Okay, that's the angle of rotation. The angle between n1 and n2, which is the normal before rotation and the normal after rotation, the angle between the two is tagged theta. Okay, so we have this is theta. So now what will be the angle of incidence for after rotation? What will be the angle of incidence after rotation? It's going to be what? This is going to be what? I plus theta. So the angle of incidence, this, let me wipe the former one I drew. Okay, the angle of the incidence will be what? I plus what? Theta. Okay, how about the angle of reflection for after rotation? What will be the angle of reflection for after rotation? It's going to be what? The angle between R2 and N2. So we have this angle is of course, you know, Snell's law says that what the angle of incidence is equal to what? Angle of reflection. Since we know this to be this, it means this becomes this too. We have I plus what? Theta as what? The angle. Okay, now let me quickly do the informations we can get from what you are seeing on the board. Okay, now this is it. The angle is the mirror is rotated through an angle theta. Okay, and the angle of reflection before rotation, the angle of incidence, sorry, before rotation is simply I. Okay, and the angle of reflection before rotation is simply R. Okay, now the angle of incidence after rotation, so we have before rotation I, the angle of incidence is equal to I, right? Now angle of reflection before rotation is R. That's this R, I. Okay, now what of after rotation? This is for before rotation. After rotation, we have the the angle between the incidence and normal 2. Okay, this was where the normal was before rotation. So the angle of incidence between the incident ray, the angle between the incident ray and the normal 2 gives us I plus theta. So this is what? Angle of incidence for after, angle of incidence for what? For after rotation. And it's also equal to what? Angle of what? Reflection for what? After rotation. Now if you are asked to calculate the angle, okay, between the incident ray and rotation, the reflected ray after rotation, between the incident ray and the what? The reflected ray after rotation. This is the reflected ray after the rotation. So it means you are calculating for this. You are finding this plus this. Okay? So this is equal to I plus theta plus I plus theta, which is the same thing as 2I plus theta. Okay? If you are confused, just let's say this is A, this is A. If you say A plus A, you have 2A. Is the same thing with what you have above. I'm still Bukola Joseph, the physics enthusiast. I hope you enjoyed today's class. Bye.